Hello friends, and welcome back to the channel. Today, we are going to do a deep dive into one of the most fundamental and widely used welding processes in the world, shielded metal arc welding, also known as SMAW or, more commonly, stick welding. This process is a great place to start our journey into welding technology. Let's begin by understanding the core principle of SMAW. The main principle of shielded metal arc welding is to use a strong electric arc to generate intense heat. This process uses a consumable electrode, which is a metal rod covered with a special flux coating. An electric current is passed through this electrode, creating an arc between its tip and the workpiece. This arc instantly creates a very high temperature, around 3600 degrees Celsius, which melts both the end of the electrode and the surface of the base metal. This forms a molten pool. As the electrode's metal core melts, it becomes the filler material that joins the two pieces of metal. Now, the key to the entire SMAW process is the flux coating on the electrode. As this coating burns in the arc, it serves two crucial purposes. First, it produces a shielding gas that protects the molten metal from atmospheric contaminants like oxygen and nitrogen. Without this protection, the weld would become brittle and weak. Second, the flux creates a layer of slag that covers the cooling weld. This slag offers further protection from the atmosphere and helps to shape the weld bead. Once the weld has cooled, this slag is chipped away to reveal the finished joint. Construction and equipment. One of the biggest advantages of the SMAW process is that its setup is known for its simplicity and portability. The main components are, first, a welding power source. This can be a transformer, rectifier, or an engine-driven generator that provides a constant current for the process. Next is the electrode holder. This tool holds the consumable electrode and is connected to the power source. It's responsible for transferring the welding current to the electrode. Then we have the ground clamp. This is attached to the workpiece to complete the electrical circuit, allowing the current to flow through the entire system and back to the machine. Of course, we also need welding cables, which are heavy-duty insulated cables that carry the current between the components. And finally, the electrode itself, which consists of the metal core wire and the flux coating. Working and operation. The SMAW process is a manual one, which means it requires a certain level of skill from the welder. Here is a step-by-step breakdown of the operation. First, the welder strikes the arc by tapping or scratching the tip of the electrode against the workpiece. Once the arc is established, the welder must maintain the arc. This means keeping a consistent distance, known as the arc length, between the electrode and the workpiece. This is crucial for a stable arc and a high-quality weld. Next, the welder moves the electrode along the joint at a steady speed. As the electrode melts, the molten metal is transferred across the arc and fills the joint. During this, the burning flux creates the protective gas shield and the molten slag, which floats on top of the weld pool. Finally, after the weld is complete, the slag solidifies into a protective crust. The welder must then use a chipping hammer and a wire brush to remove this slag, revealing the final weld bead. This is known as finishing the weld. Materials used in applications. SMAW is an incredibly versatile process that can be used on a wide range of materials. This includes carbon steels, low alloy steels, stainless steels, cast iron, and even some non-ferrous alloys. The choice of electrode is critical. Electrodes are designated by the American Welding Society, or AWS, using a number like E6010 or E7018. The first two digits indicate the tensile strength of the finished weld, while the last two digits describe the welding position and the type of flux. Because of its versatility and portability, SMAW is a favorite for many industries. Its applications include construction, pipeline welding, shipbuilding, and general repair and maintenance work, especially in outdoor remote locations. So, that was a detailed overview of shielded metal arc welding. I hope this gives you a clear understanding of the process. In our next video, we will explore gas metal arc welding, also known as MIG welding. Thank you for watching. If you found this video helpful, please like, share, and subscribe for more content.